So now we're going to look at one set of factoring methods that only works whenever you have this pattern present. It's called the sum of cubes and the difference of cubes. And if you remember, let's just do a real quick review of difference of squares. I usually called it difference of two squares because it had two terms. And actually the sum of cubes and the difference of cubes also has two terms. So if you remember correctly, whenever we had something like x squared minus 9 and we factored it, we found that the reason why there was only two terms is because the middle terms would cancel out. So if you do the FOIL method, x times x is x squared, x times negative 3 is negative 3x, the inner is positive 3x, and then the last is 3 times negative 3, which is negative 9. And what you find is when you add 3 and negative 3 and positive 3, they cancel out. So you were left with only two terms, okay? And so the pattern was generally anytime that you had two numbers, whatever a and b were, a was x, b was 9, whenever you had two terms that had been made because they were squared with something, you had this pattern. One was plus, and one was minus, okay? With cubes, it's a little bit different, okay? But there's still a pattern. So here's what we're going to do. I'm going to give you the pattern first, okay? And then I'm going to show you why it works. And we'll do that on the inside of these notes, on the inside. So let me erase this. So let me give you the pattern, okay? And this is just a memorization thing, something you're going to have to memorize, okay? So on this particular example, if we're looking at these, what we're going to find is that these are going to have a specific pattern. So let's write that pattern in. So if it's a sum of cubes, it'll look like this, okay? And here's how that pattern factors. So it's kind of similar to what we did with the difference of two squares in that the first thing is going to be a plus b, okay, because it's a plus. But the second part of it is the part that's tricky. Somewhere terms are going to have to cancel, okay? And the only way that's going to cancel is if there are some minus signs somewhere, okay? And so the minus sign is going to go in the second polynomial, and that polynomial is going to be a trinomial, okay? You probably recognize that by now. If we had two binomials, we can FOIL it, and it's going to be like an x squared, okay? But if it's got a cube in it anywhere, eventually you're going to be multiplying a binomial times a trinomial. So this is the pattern, okay? Now we're going to apply the pattern on the inside in just a minute, okay? Okay, so on this one, the difference of two cubes, or difference of cubes, has this pattern. It looks like this. The terms are made from cubing something. Now, you may not be real familiar with cubing, so I'm going to show you on a calculator how to find the cubic root of one of these, okay? So, for example, this time, the first binomial is going to be a minus, and then the trinomial is all going to be plus. As long as you have a minus sign somewhere, some of the terms are going to cancel out, okay? So they're very close. What the main thing you have to remember is that the first factor is the one that's going to kind of match the sign on the pattern. This is a sum, so the first one's a sum, the second one has a minus, but the last one's always a plus. On the difference of cubes, this one matches the fact that it's a minus, and then both of these are plus, okay? But you got to have one plus and one minus somewhere, just like we did with the difference of two squares, in order to make something cancel. So let's prove these with the inside of that foldable. This is an accordion-like foldable that I'll give you next week. So the question is, why does the sum of cubes work? Okay, so let me rewrite it there. The sum of cubes looks like this. Remember, the first one matches the sign. Then we have a squared minus ab plus b squared, okay? So why does this work? Why is this how a sum of cubes factors. So the way for us to determine that is let's go ahead and let's multiply this. Now we can't necessarily FOIL them because FOILing only works when there's binomial times binomial. But we've learned how to do this already last week, and that is that we're going to take each factor, or I'm sorry, each term in the first polynomial and multiply it by each factor in the second. And then we're going to do the same thing with the second term. So we're going to take this one and multiply it by each one in the second. Okay? And we're going to see what cancels, and you're going to find that most things cancel, and we're going to be left with this. Okay, so let's look at it. So if I were to multiply this, I would go ahead and I would multiply the a times all three of these. So a times a squared is a cubed. A times negative ab would make there be a squared, but then just a b. A times b squared would be positive ab squared. Okay, now let's do it again, but this time let's do the b. B times a squared. Well, I could write it like this, but that's also the same thing as this. They're just in a different order, okay? So if I wanted to, I could just go ahead and I could write that out as a squared b, because that's really the same thing. B times negative, b times negative ab squared, that's going to be negative ab squared. And then b times b squared is positive b cubed. So look what cancels. Here's a negative a squared b, and here's a positive a squared b. Those cancel. Here's an ab squared, and here's a negative ab squared. Those cancel. All that I'm left with is a cubed plus b cubed. So that's the pattern for sum of cubes. So if you memorize this, it's going to make things a lot easier, okay? And we're going to do that in just a minute. Okay, so why does the difference of cubes work? Okay, well, let's do the same thing. Let's write it out again. The difference of cubes looks like this, and the pattern is a little different because this one's a minus, and then everything in the second trinomial is a plus. So let's multiply it out and let's see that works. Okay, so if I were to multiply this times this, let's see what we get. Okay, so let's do the a times the a squared, that's a cubed. A times positive ab, that's positive a squared b. A times b squared is positive ab squared. But now when I get ready to do this one, it's negative b. So when I do negative b times a squared, I'm going to get negative ba squared, or if it's alphabetical order, it'll be negative a squared b. Negative b times ab is going to give me negative ab squared, and negative b times b squared is negative b cubed. So let's do the same thing. Look at my like terms. Positive a squared b, negative a squared b. They cancel. ab squared, negative ab squared. They cancel. All I'm left with is a cubed minus b cubed. And that's why it works. So if you memorize this, then it's going to make these problems a lot easier. And how are you going to recognize these problems? Well, easy. They only have two terms. Okay, so we're going to see that as we go through some more steps. So in the next video, we're going to go through and talk about how to factor, and then we're going to talk about how to solve equations by factoring. So we just take it one step further. So we're going to do some factoring examples, and then we'll do some actual examples with solving equations.